Okay, we're going to be reviewing the notes for Chapter 4, Interpreting Derivatives in Context. Tangent lines were the slope of the curve at that particular point. So that's what this means right here. You want to know, like, when it's asking what's the derivative at 1 equals 3, that means the slope of the line tangent to x equals 1 equals 3. So the slope of this line is 3, and you can kind of see it. You go over 1, you go up 3. So that's the slope of the line. Now, this doesn't have any context with it. It's just a function. It doesn't mean anything in real life. And that's kind of what we're going to do today when we start talking about slopes in context. So here are 4 important notes. X and Y don't really mean anything for a variable. Most of the time in situations we use time as t as our independent variable. So the x-axis is usually time, and then the y-axis will be whatever you're trying to measure. The derivatives right here are the units of y over the units of x. So for example, if you have, gallons right here, and then miles here, your slope would be miles per gallon because it's the y miles over the x, which is gallons. So miles per gallon. Usually it's a rate of some sort. That's what this says. The rate is approximately equal to the slope. And with derivatives, it's always the slope at that particular point. It's instantaneous. So we don't really do averages. When we're talking about the slope of a line at a point, we're talking about the instantaneous rate of change. Yeah, so when we say rates, what we mean is the rate of. We're not talking about totals, amounts, or averages. Instantaneous, that means at a particular point at time t. With the units in context, I always think y over x. It's the units of y divided by the units of x because it's slope, right? This is your rise, this is your run, y over x. There's your slope. So let's look at some of these problems in context. So for example 1 says the height of a sunflower in inches is measured over the course of 7 weeks. Use the table above to estimate the derivative at 2. Now notice 2 is in between. So we're going to try to estimate the derivative here, or the growth rate. Now, whenever you're estimating, we always use average rate of change. So we're going to use 0.1 and 3 to figure out what's the slope at that particular point, or the instantaneous rate of change at that point. So the derivative at 2 is approximately, and again, we're going to use this point and this point to estimate. So it's going to be h of 3, which is 25, minus 7, all over 3 over 1. So if we do this calculation, on the top we get 18. On the bottom we get 2. And so this equals 9. Now again, always try to include your units. So again, our units are going to be, again, y over x. Right? So our units are going to be inches, because that's the y variable, per week. And there is the solution to the problem. So basically we're saying it's about 9 inches a week. That is the instantaneous rate of change at 2. But again, we had to estimate it using average rate of change. So again, this is the derivative. Example 2. It does say the number of cars that enter a parking lot of a grocery store t hours after it opens is changing at a rate modeled by the function c prime of t, where c prime of t is measured in cars per hour. Use the table above to approximate the second derivative at 6. So again, these are in cars per hour. Right? This is at 0 hours. The parking lot is changing at 28 cars per hour. After 5 hours, the parking lot is changing by 92 cars per hour. So obviously it's getting more busy, right? And then after 7 hours after opening, right, the parking lot is changing at 54 cars per hour. So it's slightly decreasing. Now, if we were trying to estimate the second derivative at 6, that's going to be here. And again, this is the first derivative, so we're just going to use average rate of change, again, to approximate what's happening at 6 hours. So second derivative at 6 is going to be approximately the first derivative at 7 minus the first derivative at 5 divided by 7 minus 5. So again, we're taking the slope between these 2 points to find the average rate of change. So the derivative of c at 7 is going to be 54 minus 92 all over 7 minus 5. And if we take 54 minus 92, that is approximately negative 38 over 2, which is equal to negative 19. Now, we have to get our units correct here. So again, it's going to be the y variable, which is in cars per hour, divided by hours, right? And sometimes you'll see this as cars per hour squared, right? Either of those works, but the rate is changing at negative 19 cars per hour. Because again, it's this unit divided by this unit. Your y over your x. Right, so here's some pointers when you're interpreting the derivative in context. Number 1, don't just name the function. Include what the function is modeling with words. So use your words, be contextual. Include both the units for the x and the y. The x is usually time. And then always be clear that it's instantaneous. So name the time at what it's changing. And again, for this example, right, we're naming it at 6. So make sure you specify that you're finding the rate of change at time 6, at t equals 6. And then please include the word rate. So make sure you get all of the credit for your AP test. All right, so interpret your answer in context from number 1 above. So I'm going to give you a sentence frame here. So we're going to fill this in. This is kind of the sentence frame when you're interpreting your derivative. So if you look up top, right here, example 1 is right here. So what is the context? We're measuring the height of the sunflower. Now, are we increasing or decreasing? Well, this is positive 9, so we're increasing. Here's our rate at 9 inches per week. And then again, specify the time at t equals 2 weeks. Again, use units. Don't just say at t equals 2. We want to know 2 what? Is it 2 seconds, 2 hours? In this case, it's 2 weeks. So filling this in, so we'll say the height of the sunflower is it increasing or decreasing? Well, we were at positive 9, so we're going to say increasing at a rate of, what was it? It was 9. But again, use units. It does say use units. Inches per week at t equals 2. But again, please specify with units, 2 weeks. So that's kind of a sentence frame when you're using derivatives. So this is kind of a question with the sentence frame answers. I just cut and copied it because I'm lazy. You would have to write all of this out. But basically it says a factory produces delicious cans of corn for the typical corn enthusiast. I personally don't care for corn that much. Well, I mean, corn makes whiskey, so I do like corn in that respect because whiskey is amazing. But one particular machine is notorious for packing cans of corn at impressive speeds. The amount of cans this machine has packaged after t seconds is modeled by the differential function above. Right? So after 0 seconds, it's producing 16 cans of corn. Notice after 2 seconds, it's producing 52. Then it jumps up to 71, and then it jumps up to 125. So the rate is increasing here, it looks like. But let's calculate what it is. It says approximate C of 1. So that is here. So we're going to take our average rate of change between these 2 points to estimate what the derivative at 1 is. So I'll do work over here. Okay, so C of 2 is 52. So this will be 52 minus C of 0, which is 16. Yeah, over 2 minus 0. So that's 52 minus 16 is 32 over 2. I'm sorry, I can't do math. That is 36 over 2. And that equals 18. So again, what does that mean? So let's write it out. It says C prime of 1 means that what's happening, it's the amount of cans packaged. Is it increasing or decreasing? Well, it is 18, so that is increasing. What's the rate? It's 18. Again, it's y over x, so cans per second. And again, this can mean per, the divided by. At t equals 1, but again, don't just put 1, you have to put the units. So we'll say 1 second. All right, example 5. So at the end of a football game, fans, as in the fans of the football game, begin to exit the stadium. For 0 to 40, the number of fans that have exited the stadium after t minutes can be modeled by that function. Find the derivative at 8 using correct units. Interpret the meaning of this value in the context of the problem. So we have to take the derivative here ourselves. Now, we can technically do this using quotient rule, but we're going to cheat and use our calculator because we need to show our calculator more. So I'm going to show you 2 ways to find this derivative, and the answer is right here, just for reference. So let's pull up our TI. So we're going to go into the y value, the y function right here. And notice how I put my function as y1. Now note that I did put the whole denominator in parentheses, and that's so the input's correct. Now once you get this, oh, and also you always have to use x as your variable. Don't use t, just use x. Now there's 2 ways to do this. The first way is to just do a normal calculation. So let's go back to our calculator. We're going to hit second quit. Now from here, we can calculate the derivative at 8. So, notice that also, see how it says y1 right there? So the function is saved as y1. If we put it down here, it would be saved as y2. So just keep that in mind when we're doing this. All right, so here if you go to math, and math is down here. It's the 4th button down that I'm highlighting. Derivative is number 8. See how number 8 says derivative? So if I just go down and click on number 8, so it says what's the derivative you want to take? And remember, we're using y1. So the way to pull that up is to go to variables, which is right here, the one that says variables. And then on the top tab, it says y variable up here if you see it. So we're going to go to y values. Yes, go to functions, which is number 1. And there is y1. So hit it in. So we're going to take the derivative at y1, and we want it at 8. And if you hit enter, there you go. So the derivative of that function at 8 is 265.5902. So that is exactly what we got here. Now, a second way to do this is to go to graph. Once you type in your function as y1, if you hit the graph button, right? And the way I got there is if you go to zoom, which is in the middle, if you go to zoom fit, which is 0, it shows you the whole graph. Now, I can find the derivative exactly here on the graph. Now, if you notice above your button that says trace right here, it does say in blue calculate. So if you hit that calculate, which is the second, hit the second button, hit trace. Notice when you see how number 6 is the derivative. Okay, but notice how you see how we have the derivative. Now if you just type in 8 right here, 8, and hit enter, it takes you to the derivative. And notice it does say it right there. The dy dx of y1 is 65.5902. So there's a second way to do the problem. Right? So if this was a calculator option free problem, you would just say the derivative at 8 is equal to, and then please write it out. It is 265.5902. And what that means, that the number of fans that have exited, it is increasing because it's positive at a rate of 265.5902. And again, put your unit. That would be people per minute. And then at what time? At t equals 8 minutes. There you go. There's that problem. All right, lastly, example 6. It says for 0 to 10, the rate of people getting on an escalator and people per second is modeled by the function where t is measured in seconds. So notice that these units are people per second. So our derivative is going to be this unit divided by this unit. So it's going to be people per second, which usually throws people off. But it does say that this model is measuring people per second. So, for example, this is at time equals 3. What is that? At 3 seconds, there are 4 people per second getting on the escalator. Right? At 7 seconds, there is 3.5 people getting off the escalator because it is going down. Okay, so the question asks, use to find P of 8 and interpret the meeting. So P of 8. So if I go over to 8, I go up. So please don't say 3 because we're looking at the derivative. See how that says derivative? So we're looking for the slope of this line. The slope is equal to -1/2 at t equals 8. So there's the derivative at 8. Now, what does it mean? So the people getting on the escalator, is this increasing or decreasing? Well, it is negative, so it is decreasing. At what rate? And it is -1/2. Units are going to be people per second, and then per second, and then at what time? At t equals 8 seconds. And there you go.